Hello everyone. So today we are going to discuss the previous year questions, especially which are asked from periodic classification, especially periodic properties. In the last 2 days, 3 days, what we are discussing, the periodic properties. So out of those topics, I have selected 15 questions. So which are these previous year questions in JEE mains from 2016 to 2022. So these are the questions which came directly in this JEE mains. Especially more questions are from 2022 this year. So these 15 questions we will try to solve so that we will have very good clarity. So whatever the concept we have studied, so those concepts questions if you practice, definitely it will boost your confidence. So it is my only intention. So let's start the topic. So first question, the first ionization energy of sodium is given this value. For magnesium, 737 kilojoule per moles. For silicon, 786 kilojoule per moles. And they're asking what is the first ionization energy of aluminium. So for by this question, you will may worry that so should we need to remember the values of this first ionization energies of all the elements? No. It is the trick that the orders of the ionization energies we have to understood. So then we can easily identify the value from this. So how can you do that? That we know that in first period elements like sodium, magnesium, aluminium, and silicon. If you see in this case, so what is the order of first ionization energies? As I already told you, this is what 3s1 outer shell electronic configuration. This is what 3s2. This is what 3p1. This is what 3p2. So out of this, I told you for this magnesium, it is fully filled. It is what? Fully filled. When it is fully filled, I told you this is what? Highly stable. When it is highly stable, obviously its ionization energy will be more than aluminium. Its ionization energy is more than aluminium. Then what is going to happen? So sodium, then whose ionization energy will be there? More will be for aluminium. Then comes magnesium, then comes silicon. So what is the order especially? Sodium, then comes aluminium, then comes magnesium, then silicon. From this, you can identify between sodium is how much? 496, and between magnesium, 737. Between 496 and 737, which value is there? 487, which is less than 496, so it cannot be. So between 496 and 737, which is the value? 768 more than magnesium, 856 it is more than all of them. So which one is the answer? It is 577. So this 577 value lies between 496 and 737. 496 and 737. What is the aluminium? Whose value is this? 577. So this is what the how you have to find out the answer. So it is what trick about the orders as we discussed. So this is the order of what? Third period elements. Third period elements. We have also told the what is that orders of third period elements while explanation. So from that only they have indirectly asked by giving the energy values, ionization energy values, which actually don't need to remember all these values. So by knowing the order, we can guess the answer. That is what first point. Second point, they're asking they're given outermost electronic configurations of following elements. So they're giving outermost electronic configurations of these following elements, and they're asking what? Correct order of first ionization energy. Correct order of first ionization energy. From this, we can find out the elements. If they are having 3s2 is the outermost electronic configuration, then the element itself is what? Magnesium. If 3s2 3p1, it is aluminium. 3s2 3p3, phosphorus. 3s2 3p4, it is sulfur. From this, we know that magnesium is fully filled, phosphorus is half filled. From this, we can see magnesium is fully filled and phosphorus is half filled. So, from this, we know that magnesium, which is fully filled, and phosphorus is half filled. Both are what? Stable electronic configurations, and their ionization energy values are very high. From what? From their succeeding elements. From their succeeding elements. So who will have more ionization energy values? They are asking correct order. So who will have more ionization energy between magnesium and aluminium? It will be definitely magnesium will have more. So aluminium will be less. So aluminium will be less than magnesium. Then who will be between sulfur and phosphorus? Who will have more ionization energy? Definitely it will be what? phosphorus will have more ionization energy than sulfur. So what you can write? Then sulfur, then phosphorus. So this is the right order, correct order for what? Ionization energies. Hope you understood why their ionization energies orders will be written, because magnesium is fully filled and phosphorus is half filled, which are stable and their ionization energy values will be more. So due to this reason, what we can say, this magnesium ionization energy values are more than aluminium and phosphorus ionization energy values are more than sulfur. Just reversing it, we can get the correct order of their ionization energy values. Next we can see what is the first ionization energy values of beryllium, boron, nitrogen and oxygen. It is a kind of similar kind of question. They have asked for third period element and they are asking for now second period elements. So in this case, what we can say, beryllium means 1s2, boron means 2p1, outer shell electronic configuration I am writing. For nitrogen, it is 2p3. For oxygen, it is 2p4. From this also you can say 1s2, 2p1, 2p3, 2p4. So 1s2 is what? Fully filled. And 2p, nitrogen is for what? 2p3. 2p3 means half filled. So both are stable. So they will have more ionization energy than their succeeding element. That means they will have more ionization energy than boron. Beryllium will have more ionization energy than boron. Nitrogen will have more ionization energy than oxygen. So what is their ionization energy values? So we can write here like boron will be less than beryllium, then will be more than oxygen, then more will be in the group that is nitrogen. So this is the correct order. Hope you are getting my point. And next, correct order of increasing ionic radius. Increasing order of their ionic radius. And if you observe, all are what? Isoelectronic spaces. Isoelectronic spaces means they are having same number of what? Number of electrons. So isoelectronic spaces means, so the elements which are having same number of electrons but different number of protons. So in this case, what is going to happen? How will you see? The ionic radius will be more for anions. That means more is the charge of anion, so more will be their radius. More will be the radius. From this, what we can say, nitrogen will have more ionic radius than oxygen, then fluorine, then sodium, and then magnesium. This will be the order. If you observe, those who are having the cation which is having more charge, it will be of lesser charge, because so lesser will be its size. So more number of electrons are going, means more will be effective nuclear charge and the size of an atom is going to be reduced. So this would be the order. Next we can see the correct order of ionic radius of, here also they have given for what? Different orders. Like you can see, apart from potassium, the sodium, aluminium, magnesium. Sodium, aluminium, magnesium are what? They are what? Isoelectronic spaces and they belongs to same group elements. So same period elements. In this case, what is going to happen? Ionic radius. So more is the charge. What is going to happen? Lesser will be the atomic radius. So in this case, who will have more radius? Lesser radius? Aluminium, because more charge on the cation. So Al3 plus will be lesser size than Mg2 plus, then Na plus. Between Na plus and potassium, since after sodium only potassium is coming, so number of shells in potassium will be more. In number of shells in sodium will be 3, while potassium it will be 4. So its size of cation will be more than sodium. So this is the right order for what? Ionic radius. When it comes to increasing order of first ionization energy, so similar kind of questions already repeated. So magnesium, aluminium, sulfur, phosphorus and silicon. Sulfur, phosphorus, silicon. We know that this is what? 3s2, this is what? 3p1, this is what? 3p4, this is what? 3p3, this is what? 3p2. So this is what their electronic configuration. Out of this, as I told you, between magnesium and aluminum, magnesium is what? Fully filled. When it is fully filled means, what we can say? When it is fully filled means it's highly stable. So its ionization energy will be more than aluminium. Are you getting my point? Then if you can see, between phosphorus is what? Half filled. So its ionization energy will be more than its succeeding element. So phosphorus, after phosphorus, what is coming? Sulfur. So it will be more than sulfur. Then in between lies what? Silicon, that is 2p2. So what we can write, the increasing order there, that means lowest to highest. Low will be between magnesium and aluminum. Who is that? Aluminium is the lowest. Then comes more will be magnesium. Then will be for whom? Silicon. Then who will be coming between phosphorus and sulfur? Sulfur. And highest will be for phosphorus. So this is what the right order for increasing order of first ionization energy of these following elements. Similarly, increasing order of their atomic radius. Atomic radius. As you observe, see, carbon, oxygen and fluorine, they belong to same period. Atomic number 6, 8, 9. Are you getting my point? And this fluorine and bromine belongs to the group of fluorine. That is fluorine, after that chlorine, after that bromine. So I write carbon, oxygen, fluorine, then comes fluorine, then comes bromine. Now you tell me, while going in a period, atomic radius decreases, but while going in a group, atomic radius increases. Now you can tell me what is the increasing order. That means lowest will be for whom? Lowest will be fluorine. So because atomic radius is decreasing, lowest will be fluorine. Then who? Oxygen. Then who? Carbon. Then who will come? Chlorine. Then will come bromine. So this is what the order of atomic radius. Hope you are getting the point for this. Similarly, element having greatest difference between first ionization energy and second ionization energy. First ionization energy and second ionization energy. You should always remember now. You should always know element having greatest difference between first ionization energy and second ionization energy. For calcium, if you see, what is outermost electrons? It is what? 4s2. For scandium, it is what? 4s2, 3d10. 4s2, sorry, 3d1. For barium, it is what? Around, it is the sixth period element. So it will have more, you can say, it is also, we can write 6s2 in the outermost shell, 6s2. For potassium, you can say, for potassium, what is that? It's called 4s1. So, what is the question they are asking? The element having greatest difference between first ionization energy and second ionization energy. So, in this case, if one electron is gone from this calcium, so one more electron will be there in as 4s1. So, there will be not much difference in what called first ionization energy and second ionization energy. When it comes to scandium, you have to check what? Scandium and potassium. In these two cases, what is going to happen? For barium, you can see, for barium, 2 electrons are there in the S subshell. So if you remove 1 electron, that is what first ionization energy. So you have to give. And if you remove second ionization energy, that means from 6s1. So if you remove 1 more electron also, there will be not much difference in their what first ionization energy and second ionization energy. But what is going to happen? If you remove 1 electron from the 4s1, then what is going to happen? So 1 electron is gone, means it will have what? Electronic configuration of argon. Electronic configuration of argon. So after argon, potassium is coming. So argon is a noble gas configuration or inert gas configuration. So that to remove electron from inert gases, it needs huge amount of energy. It needs huge amount of energy. So for between first ionization energy and second ionization energy, it will be very high. Difference will be there in the case of ionization energy. So due to that reason, the answer will be potassium, because there is huge difference between first ionization energy and second ionization energy, because after removing 1 electron, after first ionization energy, to remove second electron, we have to apply more energy, because after removing 1 electron, so what is the configuration here? Argon. Argon means here noble gas configuration. So to remove electron from noble gases, it needs huge energy. So second ionization energy will be very maximum. So next is given 5 successive ionization energies. 5 successive ionization energy values were given. Then the number of valence electrons in the element. So how will you predict the number of valence electrons in the element? So valence electrons means for a metal especially, you can say how many electrons it can easily lose. If it is able to lose just 1 electrons easily with less energy, we can say its valence. So we can say it's a what? Valence is 1. If it loses 2 electrons easily, so its valence we can say 2. If it loses 3 electrons in the outermost shell, which can easily loses with less energy, we can say its valency can be 3. But here they have given 5 successive ionization energy values. You observe in this case, when you see 2427 kilojoules per moles. Next second ionization energy is 3000. See, 2500 around we can take. This is what 3500. It is around take. We can 3658. But when it comes to third, it is what? Around we are getting 25,000. How much? 25,024. 25,024. So that there is a huge jump in what? From second ionization energy to third ionization energy. So because of that reason, in which case there is a huge jump from second to third ionization energy. That's why, so what should be the number of valence electrons we can say? That means for third ionization energy, it needs huge amount of energy. So that's why its number of valence electrons we can say 3. So in which case, so there is a huge jump in ionization energy. What is called? That case, it will become what? How many valence electrons? 3. So to remove 1, it can be easily. For remove 2, it can be easily. For third, it needs huge amount of energy. So that means how many electrons can be easily lost? 3. Not 1, fourth one. Because it also even needs even more energy. Next we can see increasing order of their ionic radius. As we discussed, so more is the charge on the anion. More is the charge on the anion. Definitely they will have more atomic radius. So in this case, you will see this oxygen and nitrogen belongs to second period, but when it comes to sulfur and phosphorus, they belongs to, what is that? They belongs to third period. Out of this, since who will have more ionic radius? Definitely those who have what? Third period elements. Out of between sulfur and phosphorus, who has more anions charge? That means phosphorus. So increasing order they are saying. So because we have to arrange them from lowest to highest. So in this case, for oxygen O2 minus, for nitrogen it is N3 minus, because they belong to second period. First, that's why we are going to see for oxygen and nitrogen. As we know, for second period they have to fill 2 shells. For third period they have to fill 3 shells. So that's why who will have more atomic radius? Those who are having 3 shells. So for second period elements, you can see between oxygen and nitrogen, so they have 2 shells, but as I told you, more is the charge on anion, so more will be their atomic radius. So between oxygen and nitrogen, who will have? Oxygen will have less, then nitrogen will have more atomic radius. Then between sulfur and phosphorus, who has more atomic radius? Atomic anions charge, that is phosphorus. Who has less? Sulfur. So S2 minus, then P3 minus. So this is their ionic radius. Similarly, we can see increasing order of atomic radius between oxygen, sulfur, selenium and arsenic. Selenium and they are giving what? Arsenic. So if you observe, oxygen, sulfur and selenium belongs to same group elements. Oxygen, sulfur and selenium belongs to same group elements. While arsenic, these are what? 16th group elements. While arsenic is the 15th group element. Now you see the increasing order of their atomic radius. Increasing order means lowest to highest. As we know, while going down the group, number of shells are increasing. That means number of shells increases means oxygen will have 2 shells, sulfur will have 3 shells, while selenium will have 4 shells. Are you getting my point? So who has the least size or least atomic radius? That is what? Oxygen. Then next who? Sulfur. Between arsenic and selenium, they belong to same period. So who will have lesser size? Selenium. Then who has more size? That is what? Arsenic. Because in the same period, what is going to happen? Atomic radius decreases between arsenic and selenium. After arsenic, selenium is coming. So that's why selenium size is lesser than arsenic. So this is what the order for what? Atomic radius. And they're asking what is the highest ionization energy. For whom it is the highest ionization energy. Potassium, scandium, rubidium and sodium. Are you getting my point? So in this case, you can say for potassium, rubidium and sodium, apart from that, whose size will be more or less? That is for scandium. Scandium belongs to what? 3D. So it is going to come as a transition elements or 3D series element, 3D series, or it is also called transition elements. Being a transition elements, what is going to happen? The size is going to be more contracted. When the size is going to be more contracted, so what is going to happen? It will show more ionization energy. So apart from that, potassium, rubidium and sodium. So who will have more ionization energy? Scandium. And you can ask me why the potassium, rubidium, sodium being alkaline metals, they have what? They don't have much ionization energy. As we know that alkali metals being one electrons in their outermost shell, they are more prone to lose that one electron and they are highly metallic. So what is going to happen? They can easily lose that one electron. That means easily mean with less ionization energy they can lose electrons. Hope you are getting my point. So because of that reason, what you can say, so potassium, rubidium, sodium being alkali metals, they will have minimum ionization energy in the periodic table. So alkali metals. So scandium being the 3D series and transition elements, so size will be less and contracted. That's why scandium will be the highest ionization energy among these following. Next, they are given two statements. We have to see which one is right. Are you getting my point? So in statement 1, in Cl2 molecule, the covalent radius is double of the atomic radius of fluorine. See how they are bluffing. In Cl2 molecule, the covalent radius is double of the atomic radius of fluorine. So we should know that covalent radius is nothing but it's an atomic radius. How can it be double? Are you getting my point? See, what is it? Covalent radius is equals to atomic radius. So covalent radius can never be double of the atomic radius. Both are same. Covalent radius and atomic radius are same. So it cannot be double. So it is just a twisting so that it is just bluffing your mind. So that's why statement 1 is wrong. So statement 2, radius of anionic spaces. Radius of anionic spaces means negative ion or anions is always greater than their parent atomic radius. Like if you, as we discussed, let's say chlorine atom and Cl minus atom. Cl minus atom means anion spaces, like anion. Anion's atomic radius is always greater than its parent atom or its neutral atom. This is right. So more is the number of electrons gained. When an element, neutral atom, gains one electron to become stable configuration, so when it gains electron, what is going to happen? Its atomic radius is going to increase because effective nuclear charge is going to decrease, so that atomic radius is going to increase. So because of this reason, so this statement is right because anionic species radius is greater than its neutral species. But when cationic species radius is always lesser than its neutral atom. So this statement is right. So statement 2 is right, statement 1 is wrong. This should be the answer. And largest ionic radius. What they are asking? Largest ionic radius. Here you have to observe, here all of them given what? Li plus, B3 plus and F minus. They are given in the form of elementary form. Simply, those who are having just common sense, also they can answer this. What is that? These are Li plus, B3 plus and F minus. So these are what? In elementary form. Just common. But this is what? O2 2 minus is what? Peroxide form. Or what is in molecular form. So definitely molecule will have more ionic radius as compared to this atoms or these cations. Hope you are getting the point. So in this case, what you can say, so this peroxide has larger size than this Li plus, B3 plus or F minus. And even you know, in the case of this ionic radius, when I told you, in the periodic table itself, F minus is the smallest ion, smallest anion. What is the smallest anion? F minus, I told you. Even it is lesser than H minus. So in this case, what I told you is the smallest. Obviously, these two are what? Cations, Li plus, B3 plus. Generally, we know that in ionic radius itself, I told you the cation's radius is smaller than neutral, and neutral's radius is smaller than anion. So anions will have larger radius. So F minus is the smallest, we got it. So out of these three, so which one you have to select? Li plus, B3 plus, and O2 2 minus. So definitely O2 2 minus, because both are cations. So cation's radius is smaller than anion. Definitely it is what? Peroxide. So peroxide will have larger size. Is it clear? Then ionic radius of the following isoelectronic spaces increasing order. So as I told you again, they are giving isoelectronic spaces. And in the case of isoelectronic spaces, so whose atomic radius will be more? So anions radius. That means those anions which have more charge, so their atomic radius is going to be more. Are you getting my point? And those cations whose charge is more, its radius will be least. So in this case, we can see like sulfur 2 minus is given. They're asking in the form of what? Increasing order. Smallest one we can see, smallest one is calcium 2 plus, Ca 2 plus. Then it will be K plus. So between the next Cl minus and S2 minus. So these are what? Anions. So anions, what I told you, the charge of anion is more means its atomic radius is more. Then comes Cl minus, then comes S2 minus. So this is the order. And these are the 15 questions we have discussed. And if you have any doubts in this question, so please you can comment. And so I'll try to clarify. And so every time what you're going to do is, so every time I will tell you the concepts and the questions which are very much important for that concept and which came in this JEE mains or in the needs as well as. So I will discuss so that you will learn the concept as well as simultaneously you are going to practice the questions regarding those concepts. Then it will be very effective preparation. Hope it's clear and thank you all.